to their young. And he said to me, why should we? We both laughed, but it's a very big difference. And the young in the United States are taken much more seriously than they were taken in Europe 15 years ago. That has certainly changed. So when I talk about one laptop per child, or tablets, or connecting children, I think of a child like this one in Peru, where I am convinced that when she grows up, she will think differently, because her concentration, her involvement is very different than the kind of learning that comes from disciplinarian, rote teaching. Most learning in this world, sadly, is done by rote learning. You're asked to memorize things. That is truly a bad idea. But it's what everybody does. And then, what do? We test whether the child has remembered those things. Like what date a particular state joined a country, or what name of the author that wrote something. And this is not learning at all. And we need to escape from rote learning, even though 99% of learning worldwide is rote. So it's wrong. So I'm going to propose a couple of things in a few minutes that are an alternative, but they will all include rethinking childhood, rethinking the way children learn, and get rid of the concept of computer literacy. That is a stupid phrase. You don't need to be computer literate any more than you need to be a combustion engineer to drive an automobile. Computer literacy is a misguided concept. What you want children to do is to learn learning. To learn learning is very, very hard, and it's not something we think about. And we very often, we don't ask children to think about thinking, and to think about thinking about thinking. In other words, that the topic you're thinking about is thinking itself. And the closest we come is writing a computer program. When you ask a child to write a computer program, that child actually has to think about thinking. Because if the challenge is, let's say, to write a program that draws a circle, you have to express that in what's called an algorithm, and you write it in a computer language. And so when a child writes a program to draw a circle, that child is understanding circleness in a very different way. But then something even more interesting happens. And that is that the program doesn't work. Almost never will a program work the first time. So instead of a circle, something else appears on the screen. What does the child do? The child looks at the screen, obviously knows that it's not a circle, but uses the evidence, whatever's on the screen, as a way to debug the program. And then changes, and runs it again, and eventually there's a circle. And guess what? That child has experienced the closest you can get to learning. So here, in this particular photograph, and I'll show you many photographs this afternoon, this child is actually teaching in this case his grandparents, how to read and write. When I started One Laptop Per Child, I didn't realize that this would be one of the most compelling examples, because in Peru, there are about 1 million laptops, a little bit less, and almost all of them are in remote villages, very remote villages, not in cities. And in those villages, we estimate 50%, maybe it's less, it doesn't matter, it can be as low as 25% of the children are teaching their parents how to read and write. And if that doesn't put goosebumps on your goosebumps, I don't have a better story to tell you. Because the role of those children is truly different than the role of attending school as we knew it in the disciplinary model. So learning, and debugging are key to One Laptop Per Child as a project. And when we started it, we asked ourselves, could we make this affordable? And it didn't just start a few years ago. Back in 1982, before the IBM PC was introduced, actually, we brought Apple II computers to 3 parts of the world: Pakistan, Colombia, and Senegal. This was in Senegal, in a village outside of Dakar, and the child in the picture does not speak French, does not speak English, and played the keyboard like a piano. And one of the things I'm asked constantly today about One Laptop Per Child is who will teach the children how to use the laptops? And when somebody asks that question, I wonder what planet they come from. There's not a person in this room who hasn't asked a child for help. There's not a person in this room, most of you are young, who wasn't asked when you were a child for help. So this child just used it. So we knew in 1982 that was not the problem. But it took until about 2001, almost 20 years, to deploy in a village that was truly remote and had no telecommunications, no electricity, no television, no nothing. And in this village, in Cambodia, the average income at the time was $42 per year, per month, per year. And these children took these laptops home, and you'll see a satellite dish in the back that was run by a generator, and with Wi-Fi they were connected to the internet. And when they brought the laptops home, the parents loved it. Because when you open, or the child opened the laptop, it was the brightest light source in the house. And I looked at the picture, literally the picture, and said to myself, is this scalable? Could you do this on a large scale? Because here, it was the tooth fairy. It was me. I had built the school, I had paid for the laptops, my son lived in the village, connected them, and it was a charming story, but it was one village. So the question was, what in that picture would not happen through normal market forces? Telecommunications would happen, electricity would happen, but I focused on the laptop. The reason the laptop would happen is that there was no commercial interest in doing it. And when I wake up in the morning, I ask myself one question every morning, and that is, will normal market forces do what I'm doing today? And if the answer is yes, then stop. Because if normal market forces will do something, I don't need to do it. But normal market forces were not going to do this. Normal market forces were making processors faster and making software fatter. So every time you got more speed from Intel, Microsoft used more of it. And then Intel got a faster processor, and Microsoft made fatter software. And the net to us was zero. Response times went down, closing a laptop takes forever, initializing takes forever, and suddenly we found like a nuclear war that every time you did something, it was matched by obesity. And so everybody in 2001 was effectively driving an SUV that uses more fuel to move the car than the passenger. And so we asked ourselves, could we break that spell? Could we break the spell because we knew how? Could we break the spell because we had the credibility of MIT? And could we break